or you can say that you can discuss about enthalpy of atomization. More the number of unpaired electron in D subshell, stronger the enthalpy of atomization due to stronger interatomic interaction or interelectronic interaction. You can say what characters? Metallic characters. As such, scandium has more enthalpy of atomization than zinc possess 126 kilojoule per mole. This is very less. Why? Because of zinc has, what's the reason? Fully filled. What orbital? Zinc has fully filled the orbital. So you can say, if question comes in your paper, why transition metals have very, very high enthalpy of atomization? So it is because of, you can say, more the number of unpaired electrons, stronger the enthalpy of atomization. More the number of unpaired electrons, higher the melting point as well as boiling point. And the next property is the disproportionation reaction. So what is that? Why copper first is unstable in aqueous solution? The question comes in paper usually is that. So the next property is the disproportionation reaction. Those reactions in which same substances are oxidized as well as reduced, in which they show lower, higher and intermediate oxidation states are called disproportionation reaction. That is why copper first is unstable in aqueous solution, because they undergo what reaction? Disproportionation reaction at, you take copper 1 positive 2 times, copper 2 plus copper, it is the 0, it is the plus 1 and that is the plus 2. It is oxidized. This time it is oxidized because increase in positive charge. This time it is the reduced in case of plus 2, 0. So as such, if you will get any substance having oxidized as well as reduced, such reactions are known as disproportionation reaction. Now the next property is, you can see, formation of color. Transition metals and their ions have a unique tendency to form color. formation of color also depends upon the number of unpaired electrons in what subcell? D subcell. As such, due to impact of the light, they undergo DD transition, a splitting of d orbitals in their two different sets of energy. We will study in coordination chemistry. Here we don't require to explain in detail about the DD transition, but simply you can say splitting of degenerate orbitals or d orbitals in two different sets of energy. So simply, why any substance is said to be colored? Because if they are paramagnetic, if they have one unpaired electron or more than one unpaired electron, then they are definitely colored substances, otherwise they are colorless. So coloring formation is due to the presence of unpaired electrons in the D subset. For example, if I say copper sulfate 0.5 times water, blue vitriol, it is known as blue vitriol. So why copper sulfate is colored? Break the copper and sulfate to negative. Write the atomic number of the copper. This is the argon, 3d 9 and 4s 0. 9 means what? 1 unpaired is there. So it is the colored. If I say ferrous sulfate 0.7 times water, it is what color? Green color. Coloration is due to the presence of unpaired electron. You know the atomic number of the iron, argon, 3d6 and 4s 0. 6 means 10 minus 6, 4. So ferrous sulfate 0.7 times water is colored. Because why? Because they have one unpaired electron in the D subset. But zinc sulfate 0.7 times water, it is known as white vitriol. Why it is not considered as the color? Because of once you break the zinc 2 positive, 30, this is the argon, 3d10 or 4s 0. That means N has no any unpaired electron, so obviously it is colorless. So just you know the configuration, you know the atomic number, and you can predict whether the substance is colored or colorless. Depends upon the number of unpaired electron in the D subset. Now, the other feature of transition metal is very, very important. Formation of the catalyst. Catalyst depends upon the surface area, right? So, formation of what is that? Catalyst due to variation in oxidation states as well as high charge density of D block elements, they act as a good catalyst in various industrial reactions. For example, if you remember, formation of the ammonia gas by Haber's method, N2 plus 3H2, that gives 2NH3. Here iron is used as a catalyst and molybdenum as a promoter. So iron is what block? D block. So in Haber's formation, Haber's method, ammonia gas is formed on large scale or the commercial scale where iron is used as a catalyst. just you can go for formation of sulfuric acid by contact process 2SO2 plus O2. You take vanadium pentaoxide that forms 2SO3. Again, vanadium is a transition element. Another very important reaction, Oswald method for the production of nitric acid 4NH3 plus 5O2 4NO plus 6 times water. So platinum act as a catalyst. Hydrogenations of the oils and the fats are the many more examples where you will find that the number of transcendent metals are widely used to act as a catalyst. Why? Because of variation in their oxidation state, provide the large surface area, having low charge density, high charge density. These are the factors to get the formation of the catalyst. Now, formation of an alloys and interstitial compounds. Because of another property is the, you can say, formation of alloys or interstitial compounds. Actually, alloys are the blend of homogeneous mixture of two or more metals in their nearly same atomic size. Due to a smaller atomic size, of D block, they can form alloys as well as interstitial compound. For example, brass, bronze, alnico, steel. Brass is a homogeneous mixture of copper and zinc, copper and tin, aluminium, nickel plus cobalt, iron, chromium plus carbon, like this. And interstitial compounds are formed due to the Boyle formation, and here you can add the nitrogen, carbon or hydrogen. So they become very hard, stronger, and chemically they inert, and very high melting point and all that. So dear students, you have to go through all these properties of the D block elements, and then theoretical part will provide you the assignments and worksheets, but you have to go through all these properties so far as D block is concerned, and you will be enough competent to solve the questions in the final paper. Thank you very much and have a nice day to all of you.